Okay, so today, like we talked about a little bit earlier, we're going to be taking a look at this discriminant, that value that's under the square root in our quadratic equation. And what this discriminant allows us to do is, before we even use that quadratic formula, find what the actual solutions are, we can kind of know and predict what type they will be, how many of them there will be based on what that value is. And so make sure that you have this information down in your notes. If you're using those student note sheets, they are already there. But there's really 3 different options of what that value could be equal to. When you take your equation and you find b squared minus 4ac, it can either be positive. That value for b squared minus 4ac is positive, meaning there's 2 real roots. Maybe that value is negative, which tells us there's going to be 2 complex roots or 2 imaginary roots. Or that value could be 0, which means there is 1 root that is real. And so we're going to use that discriminant to kind of predict and know ahead of time what types of zeros we're going to have. Here you just see 3 different examples of kind of what that looks like. You'll notice that in this first equation right here, this number 1, if we plugged in b squared minus 4ac, you're going to get 2 real solutions, meaning there's 2 zeros here, and it crosses that x-axis. They're actual numbers. You can find what those values are. Okay, so these are 2 real. Means it's going to cross, your graph is going to cross the x-axis that many times. In the second scenario, you will, if you plugged in the opposite of b minus 4ac, we're going to get a graph that looks like this. And notice it's not crossing that x-axis anywhere. And so we're going to have zeros. We will get values for those. Just it's going to be complex values. Right? Remember that a complex value has a part of it that's imaginary. It's usually in the form a plus bi. And that graph we know will never, at least at that point, not cross our x-axis. And then this third scenario, if we plugged it into that discriminant, we're going to get a value of 0, meaning it hits that line, but it's not crossing it twice, right? There is a 0 here, but it is 1 single 0. And so we will have 1 real 0, right? 1 real solution. It will touch that x-axis, but not cross it. And so by finding that discriminant, we can kind of predict what it's going to look like and what our zeros are going to be. So let's take a look at some problems. Remember that our A, B, and C are these numbers that are out in front of those different values. It has to be written in standard form, right? So B, this here is our A, this is our B, and this value is our C. And now many of you have worked with that quadratic formula before, so you're a little familiar with that. But remember, we're not looking at the entire quadratic, just looking at that discriminant. So we want to take b squared, in this case is 7 squared, minus 4 times a times our c value. And so when we find what those values are, 7 squared is 49, and 4 times 1 times 11 is 44. And so we're going to get a value of 5. That is a positive number, which means we're going to have real solutions, and we're going to have 2 of them. Okay, so we can use that discriminant to kind of know. Let's look at this next one. Again, we want b squared, which in this case is negative 5 is b squared minus 4 times A times our C. So negative 5 squared is 25 minus 4 times 2 is 8, and 6 and 8 is 48. And so 25 minus 48 is going to give us a negative 23. Now, because this value is negative, we're going to have complex solutions. And we're going to have 2 of them. Okay, and then finally our last one, if we plug those numbers in, we're going to get 8 squared minus 4 times A is 16 times C is 1 in this case. So 8 squared is 64. 4 times 16 times 1 is also 64. And so our discriminant value is 0, which means there will be a real solution, right? It's not negative. It's not going to give us an imaginary solution, but there's only one of them. So let's take a look at a couple of problems with this. Now we're going to use that discriminant to predict how many solutions there will be, and then we're going to actually find the solution. So let's start by finding that discriminant, right? Remember that our discriminant is always b squared minus 4ac. So our discriminant here is going to be negative 4 squared minus 4 times 3 times a negative 9. So negative 4 squared is 16 minus 4 times 3 is 12 times a negative 9. And we're going to find that our answer here is a negative 108. Now be super careful about those signs, right? Because there's 2 negatives here, remember that that kind of turns into a positive. So 16 plus 108 is 124. Now because that's a positive discriminant, it means we're going to have real solutions, and we're going to have 2 of them. So we kind of know what to expect. And now what we're going to do is plug that into our quadratic. Now realize that you've already solved this part. We don't really need to plug that in again. We've already solved that, right? Our discriminant here is 124. So we're going to plug in our other values. We want the opposite of b, which in this case is 4, plus or minus 124. We already found plus or minus the square root of 124, right? We already found that value when we found the discriminant. Divided by 2 times a. So now we need to go and find out what it is. You might plug this into a calculator. You might simplify it by hand. I'm going to just do it by hand so you can kind of see what's happening here. And I'm going to start by finding that square root of 124. Right? And it's not a perfect square, which means we need to break it down. This is where your calculator, if it can give you an answer in square roots, you're okay. If not, you're going to have to go and break this down a little bit. So I'm going to simplify this as 4 times, 31. So if I go another step, I have 4 plus or minus 2 times the square root of 31. 31 is a prime number, so I can't break it down anymore. Over 6. And so what that means is one of our answers is 4 plus 2 times the square root of 31, all divided by 6. And one of our answers is 4 minus 2 times the square root of 31, all over 6. Now remember that our answers always have to be in that a plus bi form. And so we're going to just rewrite this so that it fits that form. Remember, anytime you have a denominator, we can divide both parts by it. So I will have 4/6 plus 2 times the square root of 31 over 6. And the same thing, but with a minus, right? We could have this minus here. We're going to go one more step because we need to simplify this. 4/6 should be a 2/3. And 2 over 6 can be simplified to 1/3 times the square root of 31, right? So we've taken our discriminant. We know that we should have 2 real numbers. And here we get out. We'll get one from doing plus and one from doing minus. There's no I, so there's no imaginary number there. Let's take a look at one more example. Now again, we want to start with our discriminant. So we're going to look at b squared, which in this case is -9 squared minus 4 times a times c. Well, -9 squared is 81. And 4 times 1 times 27 is 108. Which means our discriminant is going to be, let's see, 27, -27. And because it's negative, we're going to have complex solutions. But there will be 2 of them. Okay, so let's go ahead and plug it into our quadratic formula. The opposite of b is 9, plus or minus the square root. Remember, we already found that answer, right? -27 over 2a. So we can simplify this. 9 plus or minus this square root. When you think about simplifying it down, we're going to get 3i times the square root of 3 divided by 2. Now, the first thing I want you to do in the chat is, will you send me a message right now? Tell me if you see how we got this simplified fraction, square root, or not fraction, simplified radical. Do you see how we went from the square root of -27 to 3i times the square root of 3? Do you see that? Send me a message. All right, let's keep going with this, though. We now have 9 halves plus or minus 3i over 2 times the square root of 3. Here's going to be our solution. Now notice there's going to be 2 of them, one from the plus, one from the minus, and they're going to be complex solutions because we have this I right here. Okay, so a couple of really important steps. Make sure you're finding your discriminant, figuring out what kind of solutions, and then go through that quadratic formula to actually find them. As you finish this video, make sure you drop me a message in the chat. Just let me know that you're done. And tell me how you're doing with understanding. Where would you rate yourself in understanding using that discriminant?